Okay, here we go with our last two sections, sequences and series. So sequences is just the study of patterns, and what we're going to take a look at are patterns where you either add to predict the next term or you multiply to predict the next term in these last couple sections. So a sequence can be finite, has a set number of terms, or infinite, goes on and on forever. Sequences also can behave where the numbers in the pattern get larger, and that would be a diverging sequence, or the numbers in the pattern get smaller and smaller and smaller and smaller, and that would be a converging sequence where there is a specific limit to it. Okay, and so that's typically the case where the values get smaller and smaller and smaller and smaller. So here's just an example. Determine whether the sequence converges or diverges. Converges is where it goes to a specific value. Diverges is either going to grow, either up or to negative values, or it can oscillate too. Okay, so this one, it goes from 2 to 1 to 2/3 to 1/2 to 2/5. So the pattern is 2 over n, okay? So the next one would be 2 over 6, 2 over 7, 2 over 8, and so on, all the way to 2 over 100, 2 over 1,000, 2 over 1,000,000. And so if you can consider that denominator is going to continue to always grow, the value of that fraction is going to get smaller and smaller and smaller and smaller. Just like this is 0.6, this is 0.5, this is 0.4, right? So it's getting smaller and smaller and smaller. So this one is going to converge, and it is converging to 0. It won't actually get there, but that's where it's headed to. So there's that. I believe there's only just a question in the next section that will ask you about converging or diverging. All right, so let's get into what we're kind of talking about here. You will be given explicit rules for your pattern. So here's an explicit rule. We're going to come up with 4 terms and then decide if they're converging or diverging. So here's our rule, and this is subscript notation. So if I want to find the first term, u sub 1, okay, what I do is I just put a 1 in for n. So n is u sub 1, or the first term would be putting a 1 in for n and a 1 in for n. So it would be 1 plus 1 divided by 1. So u sub 1 would be 2, right? Okay. U sub 2, the second term, I'd put a 2 and a 2 in, right? So I'd have 2 plus 1 over 2. So now we have 3 over 2. Okay. U sub 3, 3 plus 1 over 3, or 4/3. Okay, and then u sub 4 would be 4 plus 1 over 4, or 5/4. Okay, so what is this thing doing? We're going from 2 to 1.5 to 1.33 to 1.2. So I would say that this is converging, and it looks like it's getting closer and closer to a value of 1 on that one. All right, C sub n, if you want to see that one. So here's an explicit rule. So the first term would be 1 to the third minus 1. Okay, so 1 minus 1 is 0. C to the second would be 2 to the third minus 2. So that's 8 minus 2, 6. The third one would be 3 to the third minus 3. So 3 times 3 is 9, times 3 is 27. So that should be 24. And C sub 4 would be 4 to the third minus 4. 4 times 4 is 16, times 4 again is 64, minus 4 is 60. So this one seems to be growing rather rapidly. I would say that this one diverges. This type of rule is called a recursive rule, and we are not testing on that. So we're going to go ahead and skip this, and you'll notice in the examples there will be some explicit rules and there will be some recursive rules. We're going to skip all the recursive rules for this year. So that's what, just to kind of narrow this down a little bit for us. Okay. So the two that we're going to focus on are arithmetic and geometric. Okay. So arithmetic, or when you add to go from one term to the next. Okay. So these are adding. So the first term might be something like 7, and the next term is 10, and the next term is 13, and 16, and so on. So we can see that we're adding 3 each time. Okay. This right here kind of gives us a format of how to figure out the explicit rule for this, but I'm just going to add a little bit to this. So any numbered term, so a sub n, we're getting used to this notation, is equal to that first term plus, so that's plus n minus 1 times d. So this is your explicit rule format for an arithmetic sequence when you're adding to go from one term to the next. What you have here, of course, is that first term. N stands for the number of terms that you're working on, and then d is the common difference. So in this example, that d would be 3. Okay, we're adding 3 every single time. So if I wanted to write an explicit rule for that, I would say any numbered term that I wanted to find would be 7 plus n minus 1 times 3. Okay. Sometimes you'll see this simplified, so like 3n minus 3, and then combine your terms. Okay, so if I simplify that, 3n minus 3 by distributing, I would get the equation 4 plus 3n. So just another simplified rule. Okay, but it gives us that same value as this one would. Okay, this is the recursive rule down here. We're not worried about that this year. Okay, so that is arithmetic. Let's take a look at a quick example other than the one that I had there. Okay, so we're gonna skip part C. We don't want to do the recursive rule. Okay, so we're gonna take a look at this pattern or this sequence. So it does say it's arithmetic, so we should be able to figure out that common difference. What are we adding every single time? Looks like we're adding 3, right? So d equals 3. So that's the common difference. So that's part A. And I'll just say d equals 3. Find the 10th term. Now this you can do at this point, and just continue to add 3 to find the 10th term. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I do that right? I hope I did. So right, first, second, third, fourth, fifth, sixth, seventh. Oh, right here I messed that up, didn't I? That's not adding 3. So that would be 19, add 3 would be 22, add 3 would be 25, right? So, okay, so you could do it that way. You could also use your explicit rule, which we're gonna do next. So we use that formula, a sub n equals a sub 1 plus n minus 1 times the common difference. So any term is equal to the first term plus n minus 1 times a common difference of 3. Okay, so I can simplify this, negative 2 plus, and that would be 3n minus 3. So a sub n has this rule of negative 5 plus 3n. Okay, so that's my rule. Okay, so I could use my rule now to find the 10th term. So if I go back up to C, I'd be like, oh, I can use this rule, and I can do a sub 10 would be equal to negative 5 plus 3 times 10, because I want to find the 10th one. So 30 minus 5, of course, is 25. So just another way you could figure it out. Okay. And I just show you something real quick on your calculator, because there's absolutely nothing wrong with just generating that sequence. But all that you really need to do is type in your first term. So if I type in negative 2 and hit enter, I get negative 2 on my screen. And then you just tell your calculator what the pattern is. And my pattern is add 3. Okay, so see what it says, it's negative 2 and then it's answer plus 3. So now all I have to do is hit enter and it will generate this pattern. So there's my first, second, and if I just continue to hit enter, so I have the 2, so that's the third one, 4, 5, 6, 7, 8, 9, 10. And you don't even have to do the thinking, your calculator will do it. So you just tell your calculator what the pattern is. Okay, so enter in again the first term, enter it, and then just do +3. And then every time you enter, it'll generate the next number in the sequence. Okay, so that's a nice way to do it too. I like, there's lots of different ways that you can figure out your terms. That's just another way. Okay, so that's arithmetic. We also have the geometric. Like I said, geometric is where you multiply to go from one term to the next. So you just have to figure out what your common ratio is. What are you multiplying by to go from one term to the next? So maybe you have something like 1, and then it's 3, and then it's 9, and then it's 27, then it's 81. You're like, oh, okay, I'm just multiplying by 3 every single time. Okay, so again, this kind of gives you what that explicit rule is going to be. I'm going to be more specific about it. So a sub n is equal to the first term times your ratio to the n minus 1 power. Okay, so my rule for this one would be any term, a sub n, any term is equal to 1 times 3 to the n minus 1 power. Okay, so that is your rule. Okay, this here again is that recursive stuff, so don't worry about that. Just make sure you know how to do the explicit rule. Okay, so it's just first term times what you're multiplying by to the n minus 1 power. Okay, so this example, all right, and again, we're going to skip the recursive, so don't worry about that. All right, so we're going to do common ratio, the 10th term, and an explicit rule. So, looks like we're multiplying by 3, doesn't it? Times 3 times 3. So R is 3. So that takes care of part A, the common ratio. Oops. R equals 3. The 10th term. So again, you could just continue this pattern on your calculator. So I would type in, to show you real quick, I type in the number 2, and then I'd hit enter, and then I just do times 3. So it says 2 is entered in, and then it says answer times 3, and I'll just hit enter. So that's the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10. So we have 39,366. 39366 is a sub 10. Okay, we got that figured out. Explicit rule, so again, just following that format in the notes, the a sub n term, any numbered term, is the first term times r to the n minus 1. So a sub n equals a first term of 2 times 3 to the n minus 1 power, and that is it. I hear you're not going to do any distributing like you did in the arithmetic, but that's just your rule. So if you want to use this to find the 10th term, you certainly can. So what you would type in is 2 times 3 to the 10 minus 1 power. Of course, 10 minus 1 is the 9th power. So if you want to just try that and see if you get the same answer we have here, I'm hopeful that it works out. So 2 times 3 caret 9. Yep, and of course it does. It gives you the 39,366. All right, so again, 2 different ways to get that 10th term. Okay, so those are both pretty straightforward examples. This last example that we're going to talk about is, what if they don't give you like the specific information? Like, you know, so it says find, it says the 3rd and the 6th terms of the sequence, 3, 4, 5, 6. So this one is 48, and the 6th term is 6. Okay, Again, we're not going to do recursive. We're going to do an explicit rule, and we're just going to do the arithmetic example, because that's all that we're going to ask of you on your test. So we're going to do an explicit rule for arithmetic. So we're going to think of this as an arithmetic sequence. Okay. Now, before they told us what the next number was, so it's really easy to figure out what we're adding. Okay. So here we can see we're adding a negative number. Okay. So to figure out my common difference, I need to take, okay, I'm going to take 6 minus 48 to figure out what is that difference. Okay. So 6 minus 48 is what, negative 42? Okay. So if this 6 was right here, I know that I would be subtracting 42, but it's not right there. It's way over here. So that's broken apart into 1, 2, 3 pieces later, 3 entries later. So I'm going to take this and divide it by 3 because there's 1, 2, 3 numbers in between that gets me to here. So 42 divided by 3, I believe, is 14. So it would be a negative 14. So let's just check that out. If I subtract 14, I should get 34. If I subtract 14, I should get 20. And if I subtract 14, I should get 6. And so it does seem like that's working. That is the common difference. Okay, so we have figured out that the common difference is negative 14. Okay. Now, if I am going to write the rule, I need to know the first term. So we're just going to go ahead and work backwards and find that first term. So if I'm going to go this way, I'm going to add 14, right? Okay. So that would be what, 62 if I add 14. If I add 14 again, that should be 76. Okay. To find that first term. And okay, so there we go. Now we have everything we need to write that explicit rule. Again, this is arithmetic, so a sub n is equal to first term plus n minus 1 times that common difference. Okay. So as we substitute in, we've got all that info now. So a sub n is equal to 76 plus n minus 1 times a negative 14. Just be careful here. This is a negative 14. So make sure when you distribute to clean this up that you're careful with that negative. So 76, and then that would be a negative 14n, and that would be a positive 14. Okay, if you see my distributing through there. All right, so then I can add my 76 and my 14, which would be 90. 90 minus 14n should be the rule. Then if you ever want to check to see if your rule is right, just put in a 1 for n and see if it gives you 76. Put in a 3 for n and see if it gives you 48. Now you can try your rules once you get them figured out and see if they actually do work. Okay, so that's the last type of question that you're going to have from this section on the quiz. And I think that's it. Let me just double check here. Fibonacci sequence not going to be on the quiz, so we just have these 4 examples. So 676, number 3, 23, 29, and 25. So give those a try. And then we have 1 section left. You guys have almost made it.